This presentation speaks to how to measure noise, how to measure sound. It is a very complicated subject. We will try to reduce it to its basic terms to make for easy understanding. There is constant sound at some level around us at all times. Most annoying sound emanates from mechanical machinery and not from natural sources. Noise can be a very real and annoying thing as we actually feel the noise waves. There are many different sources, even computer fans. This can get aggravating if your CPU is up at ear level. Noise cancellation is a full-time business for sound experts. To measure sound, we speak of measuring it in units called decibels. The level measured when doing sound measurement is an indication of how loud a sound is. The sound we want to measure is that sound which is caused by building mechanical systems. A background sound level check can be done with the mechanical systems off. Another set of readings can be done with the mechanical equipment on. This differential noise measurement provides for a base sound level reading. To measure sound is done using a sound meter in an all-pass mode, where all the discernible frequencies are included. Sound may also be measured in the calibrated bandpass mode, where the decibel level is measured at 9 different frequency ranges: 31.5 Hz, 63 Hz, 125 Hz, 250 Hz, 500 Hz, 1000 Hz, 2000 Hz, 4000 Hz, and 8000 Hz. This is the normal discernible hearing range for most people. Noise levels of various sound producers: 150 decibels, jet plane; 140 decibels, an explosion; 130 decibels, artillery fire, machine gun, riveting; 120 decibels, siren at 100-foot sonic boom; 110 decibel, woodworking shop; 100 decibel, subway, lawnmower, outboard motor; 90 decibels, truck train whistle, kitchen blender, jackhammer; 80 decibels, printing press, noisy office; 70 decibels, average street noise, average radio; 60 decibels, noisy home, average office, normal conversation; 50 decibels, general office, radio, average home; 40 decibels, private office, moderately quiet home; 35 decibels, quiet conversation; 20 decibels, empty auditorium, faint whispering; 10 decibels, rustling leaves, human breathing. Noise levels or sound levels are also expressed in different ways, but the most common and most used method is the noise criteria curve. This curve is based on how the human ear reacts to a sound level and its corresponding frequency. To get a little technical for a moment, the ear reacts to sound pressure. Therefore, the NC curve is a varying pressure curve, where a decibel of sound measurement is referenced to a pressure level of 0.002 microbars. A microbar is approximately 1/1,000,000th of the normal atmospheric curve. The NC curve chart is made up of several sound pressures, ranging from NC10 to NC70. The decibel level for each frequency: 31.5 Hz, 63 Hz, 125 Hz, 250 Hz, 500 Hz, 1000 Hz, 2000 Hz, 4000 Hz, and 8000 Hz is plotted on the noise criteria curve. The graph curve closest to the parallel plotted curve indicates the noise criteria level. The measurement of sound power can be stated in decibel levels or in noise criteria. I hope that information helps you. Thanks for listening. Bye now.